Here we are given y is equal to x plus under root x square plus 1 raised to the power m, and this is what we have to prove. Now let's say if I find differentiation in the first go, finding differentiation of this. So differentiating both sides with respect to x. So it's going to be dy by dx, and this will give you m times x plus under root x square plus 1 raised to the power m minus 1. So I use the property x raised to the power n differentiation is nx raised to the power n minus 1. Now further applying quotient rule here, the chain rule here, what you can see that differentiation of x, which is 1, root x differentiation is 1 by 2 root x, 1 by 2 root x. Well, this is taken as x. This whole thing is x. That's and root x is 1 by 2 root x. And again, by chain rule, the differentiation of this x square plus 1 is 2x. Right. So we see that this get cancelled here. Now, what I can see that in the RHS, we need m as well. We need dy. We need y as well. So this is the reason why I'm going to make this similar to y. Now, this is possible if I apply the laws of exponent here. So this is m x plus what we know, like x raised to the power n minus 1 is what? X raised to the power n over x. That is what I'm going to do in this case. So this is x raised to the power, that's m over the same thing, that is x plus under root x square plus 1. Now, next, simplifying this, I'm taking LCM here. So it will give you x square plus 1 plus x over under root x square plus 1. Now check, we are finding that these get cancelled here. This and this get cancelled. In the next step, what I'm doing is transposing this to the left-hand side. Now, why I'm thinking like that? Because I can see that we need this thing along with dy by dx. That's why I'm transposing this to the left-hand side. So if I do so, what we'll get? We'll get x square plus 1 times of dy by dx is equal to what you can observe that this whole thing can be replaced with y, this one. You can see that this can be replaced. This can be replaced with y. Once again. Yeah. So I can replace this with y here. Now, if this becomes y, this becomes, so this is my, right? So we are just left with this part, and now we'll be applying, it's a second order derivative. As you can see in the question, we also have to find d square y by dx square. That's why we'll finding its second order derivative. Let's do it here. Right, finding its second order derivative, once again differentiating both sides with respect to x. Now, product rule on the left hand side, root x differentiation is 1 by 2 root x, 1 by 2 root x. And by product rule, x square plus 1 differentiation is 2x. Then this is u dash. Now this is v plus uv dash. That means this will be x square plus 1. And differentiation of this is what? D square y by dx square. Now that is equal to, on the other side, this is m being coefficient and this is dy by dx. Now we can see that we need m square. Okay. First of all, let's see what we can resolve. This is getting cancelled. And we need a square of this. That means multiplying this, multiplying both sides with respect to, multiplying both sides with respect to this thing. That is by this x square plus 1. If I multiply on both sides, I can see this get cancelled, right? So we'll have x over nothing because this get cancelled, multiplying both sides with this. X over dy by dx and plus square, multiplying this with the same thing, root x into root x is x. So it's going to be x square plus 1. And then this is d square y by dx square. And this is m times root x square plus 1 dy by dx. So we got, yeah, this is what m is coming on the other side. Yeah, I just figured out that I can replace this thing from here, from equation 1. Let's say if I mark this as equation 1, what I can replace this with, this can be replaced with my, right? I can show you this thing. Yeah, this you can replace with my here. As you can see that this is my. So now if I proceed this further, we have x times dy by dx plus x square plus 1 times d square y by dx square. And this is, there is already m and this is my. So it's going to be m square y. So now next step, just transpose this to the left hand side. It will become minus on the other side equal to 0. I think we got it. Just that some rearrangement is there of order in which it is written.